In this example, we're going to continue to look at fractions in context, and this time we're going to look at the part-whole model. So our directions again are to represent the following as fractions. So let's look at the first problem and highlight important information. So 4 out of 6 people in the coffee shop have brown hair. That's our given information. And our goal is what fraction of people in the coffee shop have brown hair. So you may remember from the first video that when we have language like 4 out of 6, that represents a fraction. Okay? And we would write 4 out of 6 as 4 over 6. So this is our fraction form. So this is a fraction of people in the coffee shop that have brown hair. And I'm going to box this in so we know this is our answer. But let's just look at this a little bit more deeply so we can compare and contrast it to the last type of problem, the division or quotient model. Okay. Notice here that we're not dividing the 4 people with brown hair amongst the 6 people in the coffee shop. So this really isn't a division problem. This is representing a part out of a whole. Okay? So this is another way to think of a fraction. And in a part over whole problem, since a part is typically smaller than a whole, okay, this will be a fraction less than 1, where the number on top is smaller than the number on bottom. And in this case in particular, you can determine what the whole is by reading the question. So notice it says, what fraction of people in the coffee shop have brown hair? So this is telling us that our whole, what we're looking at, is all the people in the coffee shop and the part is specifically the people that have brown hair that are in the coffee shop. Okay. So a lot of times in part-whole problems, the question has the specific term after the general term. So the general term being the whole or the total. And then they talk about the specific second. So the 4 people have brown hair, and the 6 people are all the people in the coffee shop. Let's look at the next question. On a quiz, John answered 3 questions correctly and 2 questions incorrectly. That's our given information. What fraction of questions did he answer correctly? So this is going to be a part-whole problem because they're asking what fraction of questions, so the questions, all of the questions, are going to be our whole. Did he answer correctly? So the correctly is going to be the part. Okay. So let's put number correctly over total number of questions. Okay. So it may be tempting to look at this problem and see, oh, there are my numbers 3 and 2. I can make a fraction out of those, put one over the other, maybe 3 over 2 or 2 over 3. But you have to be careful because it's specifying by this statement what fraction of questions. Okay, that the of questions is telling us that we're talking about all of the questions. So that would include both correct questions and incorrect questions. So they tell us exactly the correct questions, which were 3. And the total number of questions would be the correct questions plus the incorrect questions. Okay, so we need to combine those 2 amounts to find the total number of questions. So 3/5, or 3 out of 5, is our fraction. Okay. And before we move on to the next video, I just want to take a second to think about what this means and how we're using a division operator, even though we talked about how we're not really dividing. We're not dividing the correct questions by the total number of questions. In the future, we will do that to maybe write this as a decimal or a percentage like you've probably seen on a test you've taken before. And that's a nice part of mathematics, is that we can use this type of division even though this isn't specifically a division problem. Okay? But what we're really doing is we're making what we call a multiplicative comparison. So what does it mean to be multiplicative? So we can say that I know that he got 3 questions correct and 2 questions incorrect. So if you subtract these values, the difference between 3 and 5 is 2, and that's telling us the part he got incorrect. So the incorrect part would be 2/5 of the questions. But the difference between 3 and 5 is 2, but let's look at another one that has a difference of 2. So say you took a test, let's imagine that you took a test and you got 98 correct out of 100. Okay, so this is a very good score. We'd probably say, okay, we haven't discussed these concepts, but I'm thinking you've seen this before. Maybe you got you might say you got a 98 on the test, or you got a 98% on the test. Okay, and if these concepts are bothering you, don't worry, we'll talk about them in great detail later, but I just want you to see the idea. So the difference, the subtraction between these two is -2. Okay, but this is a much better score than 3 out of 5. And let's think about why. So even though the difference here is 2, in both of these situations, okay, in this problem you got a lot more correct relative to the amount of questions. Okay, so you can think about, well, in this situation, say you took this test and on the first 5 you got 3 correct, and then you continued. You'd have to get another 95 questions in a row, every single one of them correct, if we think about it having 100 questions. Okay. So getting 2 wrong on 100 questions is a lot better than getting 2 wrong on 5 questions. So this is what we mean when we say we're comparing things multiplicatively. So here we say additively, we're subtracting or finding the difference. That's one way to compare things. Okay, but here we're thinking about relative to some total amount. And the difference does tell us some information, but when we start talking about fractions, we really want to think about the relative difference between these two. Okay, so I hope you can see that this would be a much better score than getting 3 out of 5, because relative to the total number of questions, you got more questions correct, even though the number you got wrong in each case is the same. In the next video, we're going to look at a part-to-part comparison.